Good afternoon, everyone. It is my pleasure to give a presentation here. I am Han Li from Beijing Institute of Technology. Today, I would like to introduce a semantic modeling method using high-level architecture. It is support the integration of digital twin. I will introduce from the following five parts: introduction, related works, digital twin integration, case study, and conclusion. First, in the introduction, developers of complex systems face an emergent challenge in the integration of heterogeneous complex systems across domains. A system of systems, we call the SOS, has been proposed to define such a situation as a set of system elements that interact to provide a unique capability that none of the constituent systems can accomplish on its own. Digital twin has been widely used to support system of system analysis and development. When building digital twin for a SOS, it is necessary to integrate virtual entities in different domains, which is a challenging task due to the high heterogeneity. First, the interface specifications should be defined in a standardized approach. Second, when implementing the integrated simulation across digital twins, runtime and synchronized communications are required to support data exchange across digital twins. Second, the third users expressed the service integration of different digital twins. For those reasons, we think that digital twin integration requires a unified specification to represent domain-specific knowledge of each constituent system, and a standardized framework is needed to combine digital twins for integrated simulation across an SOS. So in this paper, we propose a unified ontology to support domain-specific knowledge management between digital twins. Besides, we use high-level architecture we call HLA to support the interface integration between heterogeneous digital twins. Second is related works. Semantic modeling has been widely used to describe domain-specific knowledge. However, it still lacks a unified architecture and can't solve the challenge of integrating different domain-specific knowledge. Integration of digital twins is challenging because of heterogeneous state and model structures during SOS development. Currently, HLA, DCP are widely used to support digital twin and model integration. That is digital twin integration. There is our methodology. First, we propose a semantic modeling approach to describe the topologies between virtual entities. The GOPPRR meta-modeling approach provides standardized and semantic expression for different data structures, and ontology web language we call OWL is used as the basis of semantic modeling. Second, in order to define standardized interfaces of heterogeneous digital twin, the distributed simulation is used based on HLA. We use this semantic modeling approach to develop a ontology model. It represents HLA model and can support digital twin integration. Our semantic modeling approach is based on the GOPPRR method. It is a modeling framework based on a M0 to M3 framework. The M0 layer represents the physical entities of digital twin in the real world. The M1 layer represents virtual entities. The M2 layer represents meta-models, and the M3 layer represents 6 meta-meta models, including graph, object, relationship, property, role, and point. Graph is a collection of objects, relationships, and their connections. Object refers to a basic entity in the graph, representing one thing independent of the relationship and the rule. Property refers to one attribute of the other 5 meta-meta models, describing their characteristics. Point distributes one port in the object that is connected to the relationship. Relationship is used to indicate how objects are connected. Role is used to indicate one connection of objects and relationships. OWL can completely express the information in the semantic modeling process and is used to describe the GOPPRR information in this paper. The class is used to define GOPPRR meta-meta model, and its subclasses are used to describe meta-model. The object property is used to represent the interaction relationship among the 6 meta-meta models, such as inclusion, binding, and so on. The individual represents models referring to the information of specific digital twin virtual entities. HLA is used to define standardized interaction. It is a universal standard protocol for distributed simulation. It provides a set of rules based on the following main conception to achieve interoperability and reusability when constructing the standardized interface for digital twins. Federation is a simulation application composed of a set of simulation components. Federate is one simulation component that represents the basic elements of HLA. Runtime infrastructure, we call RTI, is a simulation-oriented middleware for managing alliance interaction. In HLA, Federate is a basic component for the distributed simulation. When integrating digital twin and HLA, Federate and virtual entities constructed the digital twin federate we call DTF.